Okay, so today we'll be talking about PCR. PCR. And PCR stands for polymerase chain reaction. So what a PCR does is it takes your wanted DNA sequence and it copies it like a million times, so you have a ton of copies of it. So you have like 5 essential things. And so you'll have like a DNA template, primers that attach to the wanted ends of your DNA sequence, DNA nucleotide bases like adenine, guanine, cytosine, and thymine, Taq polymerase enzymes, and buffers, so you have the right conditions for your PCR reaction to occur. So in the first step of PCR, it's denaturation. So as we all know, DNA is double-stranded. So what denaturation does is the temperature rises to about above 90 degrees, around 90 degrees, whatever is best, and it takes that double-stranded DNA and separates it into 2 single strands. Okay? So next, after denaturation, we have annealing. So when annealing is time for it to occur, the temperature lowers to about 50 to 60 degrees Celsius. Sorry, I forgot to say Celsius. And so once your DNA is separated into 2 separate single strands, then you have primers that come in and they attach to the end of that wanted DNA sequence. And these primers are made complementary so that they match up with your nucleotides on your wanted DNA sequence. And after that, there's extension. And so at extension, your temperature rises once again but this time only to about like 72 degrees Celsius. And so you'll have your single strands and your primer attached to them. And then Taq polymerase, which stands for Thermos aquaticus. It's called that because it's able to withstand high temperatures. So it's able to extend. So it extends those primers along so it can copy that DNA strand. And then you're left with a copy of each of them. So basically, in a big picture, you start out with that double-stranded DNA strand, and then he separates it into two single strands. And then you have your primers that attach, and then your Taq polymerase enzymes that come in to extend those primers, so then it copies. And so then it repeats that 3-step process over and over again until you don't want to do it anymore, normally about 30 to 40 times. And so as it just keeps going, this strand copies, this strand copies, and you also have this strand that copies, and this strand that copies. So if you obviously you can see if you keep going, you just like all of a sudden gather all these multiple copies, and it comes out to like millions of them. And that is PCR. And this are my citations.